So I'm making a separate video, so it'll be nice and short, a video teaching you how to rationalize the denominator. Now, how do you know if your answer is fully simplified? How do you know if you're done? Okay, well, the radicand can't have any perfect squares left. So if you have like 3 root 4 over 7, whoa, you've still got a radicand with a perfect square. So that would not be simplified. The radicand has no fractions. So you have 10 root 3/7. You've got some work to do. The radicand is not allowed to have fractions. So both of those are illegal. And then this last one, to be a fully simplified in the math world problem, you're not supposed to have any radicals in the denominator. So for example, that would not be a fully simplified answer. Now, if we're not allowed to have radicals in the denominator, how are we going to get rid of those radicals? How do we move the root 5 out of the denominator?
The 3 and the root 5.
Okay, so I'm going to teach you how to do that. It is called rationalizing the denominator. Get it? We're trying to make the denominator rational because right now it's irrational. So it's called rationalizing the denominator. We're going to use sheer willpower and math skills to make the denominator rational. The only way to fight a radical is with another radical, which means you are squaring it. Yes. So the way we're going to get rid of this radical, yes, we could square it, but when you're not allowed, if I just square this, I have now changed the problem. I need to do something to 1 over root 3 that will not change my problem. I'm not allowed to change it. I can't, then my answer is totally different. So do you agree that if I multiply this by 1, I'm not changing the problem at all? Do you agree?
Yes.
Okay. But I'm not going to multiply it by just 1. I'm going to multiply it by the fanciest one you've ever seen. So I'm going to multiply it by a very specific number 1. Look at this. Do you agree that root 3 over root 3 equals 1?
Yes.
Whoa! So I'm multiplying this by 1, but it's a very specifically chosen 1. Because watch what happens. Let's multiply across our denominator. Let's multiply across. Do you know what square root 3 times square root 3 is?
Square root 9.
Okay, which is?
3.
It's just 3. Yeah, that's like saying square root of 3 squared. Those cancel. You don't even have to go the root 9 route. And then the numerator is 1 times root 3, which is just root 3. I know this is really hard to grasp the fact that root 3 over 3 is actually more simple than 1 over root 3, but just someone decided that it's not proper to have radicals in the denominator, and now that's the reality we live in. So root 3 over 3 is actually the simplified answer. So it's really important to understand how this works. What is square root 3 times square root 3? Yell it at me.
3.
3. What is square root 27 times square root of 27? 27. What is square root of 1,289 times square root of 1,289?
1,289.
Thank you. Okay? It's very important to know that when you multiply the same radical by itself, they cancel. For those of you who can stay, I'm going to go ahead and do the rest of the examples. Okay. I spy a radical in the denominator, but I also spy a perfect square. So it's up to me which one I want to tackle first. I'm going to tackle this first. There we go. It's 2. Now I'm going to rationalize the denominator. So across the bottom, what's square root 5 times square root 5? 5. And then 2 times root 5 is just root 5. And like I said, believe it or not, that is the simplified answer, even if the first one looks more simple than that. Okay, this guy's pretty basic, trying to keep it easy for now. How am I picking this number? Square root 3, square root 2, square root 5. How do I pick?
It's the same as the denominator.
Whatever the denominator is. Very good. If we want to fight root 2, we can only fight it with a root 2. So the numerator is 1 root 2. I'm choosing not to write the 1. Square root 2 times square root 2 is plain old 2. The square roots cancel. The square roots cancel.
What happens when the bottom is like, oh, never mind.
Do you see one here that would?
Yeah.
Okay. All right. Bye. I'm allowed to, so I'm going to write these separately. So you're more than allowed to do that. You can put this example in your notes so you can remember, oh, I'm allowed to break that fraction up and divide the numerator and the denominator. Now I'm illegal. I've got a radical in the denominator. So I'm going to rationalize. When I multiply across the bottom, I get 3. Now when I multiply across the top, I'm allowed to multiply these because they're both radicands. So I get root 6 this time. You see the difference? You do multiply the 2 times the 3 because they are both radicands. You're allowed to multiply them. Okay. What should we do here? We have so many choices. I would not rationalize until it's simplified. That's what I would do. No, that is already simplified. I'm so sorry. Okay, let's go across. Yeah.
When you multiply the denominators, wouldn't it be the square root of 9?
Yeah, but that's not simplified. What is the square root of 9? It's a perfect square.
Oh, okay.
Yeah, there you go.
Okay.
Oh no, I lost my pen. Root 6 over 4. I lost my pen somehow. Root 6 over 4. I'm frozen. So the root 6 stays. It's not letting me write. And the 3 and the 12 cancel out and get 4.